Biometrical study of orthopedic implants for distal fibula in type A fractures. Es una presentation from Milton Alfredo Perez Reyes, Dr. Juan Alfonso Beltrán Fernández, Belén Alejandra Contreras Mendoza, Elías Humberto Hermidia Ochoa, Dr. Alejandro González Rebatú y González, Kenia Maidelen Ortiz Morales y Juan Antonio Sánchez. Abstract. The following research present the outcomes of structural mechanical analysis conducted on an implant designed of type B ankle fracture rehabilitation with an obvious implication in patients undergoing a therapeutic rehabilitation process. The study is centered around 40 years of male subject weight 19 kilos and standard height of 1.8 meters. Keyword: prosthesis impact 3D printing, stenographic models, bone, finite element method. Introduction. Ankle fractures are a common clinical problem with an incidence of 1.878 per 100 people per year. Type B fractures are mainly caused by supination of the foot and external rotation to have also been associated with obesity and diabetes. The goal of treatment for type B fracture is to reduce the displacement of the fracture fragments and thus maintain anatomic alignment. Locking plates are recommended for distal fibular treatment as they prevent screw loosening by providing a more rigid threatening plate construction. Image 2. The present analysis addresses a real clinical case of distal fibular fracture instrument with a locking compression plate LCP applying a vertical compression force of 90 kilograms with its patient body weight and consider a load of 2684. Due to that, we're walking in the median stem press at this charge of 3 times the body weight is found. Methodology. The analysis of biomedical behavior using a fine element method or recurrence generation ACAD model. The first step is to obtain the DICOM image to the patient undergoes a CT scan and is subsequently analyzed in a microdyne scan viewer, open source. One of the images as obtained are segmented and carried allows the image to be divided into parts. This allows generation is accurate model of the domain of interest, figure 1. For analysis by defined element methods, discretion of the element be analyzed, referred mesh is made in the dominant for 5. Model segmentation. Obtaining 3D biometrical using scan IP, segmentation of the study are a creation of 3D biomodel. Plan design. Parameter metallization of the plate, compression system, and locking system using space claim. Assembly of the plate to the biomodel. Fracture simulation are present on the plate. Hardware and compression system. Numerical analysis experimental. Numerical and experimental preparation of the biomodel. Numerical analysis is analysis. Figure 1. Model applied. It's important to have adequate image to allow the development of the required model. In this case, the model to be delivered as skeleton in a neutral position without weight. Figure 2. With analysis space claim, which is used for the construction of the plate implant, the extrusion and combination tools are used inside the interface, and 6 vertical pins into cancellous pins are inserted. Figure 3. The measure is generator deformation, digital image correlation, DIC, is used using the GOM correlate software. It is important to claim the impact of 70 ethanol eliminated to the presence of greasy or teeth. Figure 4. Results. The results show that the maximum stress is 1 for 3.39 MPa. This analysis was displayed while the joint these are tensile stress of 12.917 MPa with a maximum lateral displacement of 0.36346 millimeters, figure 5 and 6. The test was performed on a compact PLL printed sample for the plate load on a hydraulical test machine, figure 7, analyzed using single camera T configuration in the GUM correlate software, resulting in 0.127 on strain on the color spectrum scale, as we can see on the figure 7. Conclusion: tensile stress decrease after intersection on plan on the type B fracture surface according to the result obtained. It is shown on the impact support forces extended on the ankle contribute to the adequate rehabilitation on the patient. The limitations on this study are loading condition on the position on the ankle that I consider the model of the analysis of the distribution of the force stress in the ankle joint. It's important to mention that muscle forces are not considered the present analysis since there is no information in the literature on those. In a digital image correlation test, data collection, data analysis, and data presentation, the results are considered and interpreted from some biomedical consideration, where is the useful and compared when with a model by the finite element method, specifically with implants for type B fracture, since with insertion of this implant deformation and the stress can be reduced. Surgeon can evaluate the advantage and mechanical behavior on this type of implants. In addition, the loading condition, essential medical criteria for this numerical and experimental test. Acknowledged. The institution Polytechnic Nacional and the hospital 1st October and contribution made during the results Biomedical Research Center and Laboratory Carmel 918 Chimalistac San Angel 0107 Mexico City.